Hello everyone, this is a video lecture for College Algebra, Math 1314, Section 2.5. And so this is actually going to be called Transformations, but I'm also going to be doing this video differently than the other ones that I've been doing so far. I'm not going to be posting any questions like that are pre-written. I'm just going to have to actually lecture and talk about it for a little bit, and I'll give you a couple examples near the end. So as you can see, there's no other questions. We're just going to start working. So what transformations are is three different types that we'll be talking about. We got shifting, and then we have reflecting, and then we have stretching, shrinking. There's a few words I'd use for that. That's maybe the official ones. Compressing, scaling, zooming. There's a lot of different ways to say that, but again, we'll get there eventually. So shifting, there's two different types. We have the vertical shifting. And I'll give you examples on all this stuff in a second. Vertical, and we also have horizontal. So vertical mathematically is an f of x plus or minus c on the outside. Horizontal is going to be a minus plus on the inside. And I'm just going to put a little reminder here. Anytime you see inside, you need to think opposites. Inside, opposites. Inside, opposites. So let's give you, I guess, a small little example for each of these as we get going. So vertical shifting is taking some kind of original graph that we have. I'm just going to use the square root function for a bit. And it goes up. So it'll look something kind of like that. Could also go down. Something kind of like this is also acceptable. I don't want to clutter it, though. But up or down, vertical. Horizontal is side to side. So I got my original square root, and now you go to the right. Or again, you can go to the left. But I'm just going to use just the one there. Now, the inside opposites is kind of strange, and we'll be doing some examples on that here in just a second. Let me finish off this page, and then we'll do lots of cool examples. So reflecting, we have either the x-axis reflection or the y-axis reflection, and that's going to be negative f of x versus f of negative x. So again, let's say I start with this, and I'm going to reflect it about the x-axis. That's right here, and so it would look like that going down. The y-axis reflection, y-axis is right here, and it would go to the side. So those are the two different types that you see there. Stretching and shrinking is not so easy to show with graphs, especially by hand like what I'm doing. But there are two different kinds. I guess I can go ahead and list them. So we have vertical stretching is c times f of x. C is just a number in the front, like a 2 or a 3. And it's going to stretch it vertically, meaning that it's going to go higher. So it could be 2 means double the height. A half would mean half as high. And then we got horizontal, which would be f of c times x. And notice again, inside, opposites. So we're going to have to think opposites on this one as well. And I'm just going to try to graph it, I guess, right now. So we have some kind of original graph here, and then it's going to look like that because I'm stretching it horizontally, something kind of like this side to side. Again, though, these are a little bit more fluid, and we'll talk about that later. I'm not really concerned about that stuff. The shifting is very important, and the reflecting is the most confusing. So let's do a ton of examples. And before I go, I want to say that I've been using this f of x all the time. Let's just do f. It's fine. So f. What I mean by f is function, of course, but it's also going to be my graph. And right here in this case, my original f of x, as you've seen it every time, was this kind of shape. Because what I actually have is the square root of x. That's what I was saying. So it's the square root of x is that shape that I used here as an example. Well, there's a lot of different shapes possible. So let me give you a couple of those so that we're kind of familiar with what pictures that we're going to see. And so let's just say that I had, let's just do X. So we got plain old X, and that's going to be a 45-degree line. It's related to the lines that we just saw with the mx plus b stuff, which again could be any kind of line, positive or negative. Another one that's common is x squared. So that's going to be a parabola shape, something kind of like this. We also have x cubed, which would be a cubic, looks something like that. We have, of course, the square root of x, which is what I just showed you a second ago. That's a poor representation. There you go. It does a whoosh. And then we have the cube root of x, which is kind of like a double whoosh. I don't know, there's one on both sides. And yet again, there's another one. There's the absolute value of x, which is a V shape. It looks something like that. 45 degrees is its standard, but you can move it around and shift it around as you need, stretch it. So with all these different pictures, when I start making examples, you can kind of go back to these pictures and say, oh, square root, he's talking about this picture. Oh, x squared, he's talking about that picture. And what we're going to do is just manipulate that picture accordingly. So, for example, and this is where we're actually doing the math now, let's just say that I had x squared plus 3. And that's it. Y equals x squared plus 3. Graph it. Notice that we have this plus 3 is actually going to be going up. Whenever you have something on the outside, it's vertical. And so we're going to take our original parabola shape, and we're going to go up 1, 2, 3, and then we just draw it right there. There it is. You're done. Let's do another one similar to that. Let's do x squared minus 4. Notice that the minus 4 is on the outside. That means it's going to go down. And so then I got 1, 2, 3, 4. Original, again, looks something kind of like this. But then my new one looks something like that. And it'll keep going. I just stopped it early, I guess. So all I'm doing is taking my original location and I'm moving it up or down. Very simple. Let's do some more. Let's say now that I have x minus 3 squared. Notice that this is on the inside. Inside, opposites. At least that's how I think about this. I'm seeing that this is a negative 3, but where I'm actually going is into positive 3 land. So my original, again, looks something kind of like this, and then my new one is going to look like that. So that's it, inside opposite. So why is it that we're actually using a positive 3 instead of a negative 3 like it looks like? Well, I'm going to just give you an example here of how this works. Right here, don't look at anything else, just look right here. Look right here, and I'm going to ask you a small question. Right here, don't even look at that, don't look at this, don't look at anything else. Solve for x. Solve for x. What's the answer? It's 3. What kind of 3? It's positive 3. And you just know that. I know, I'm going to do the math on the side. You just know this stuff. I know you know it because you're here. You're watching my videos. Positive 3. That's another proof as to why we're actually at positive 3 instead of, say, like negative. And let's do another one here. So I'm just using parabolas apparently because I like parabolas today. So we got a positive 4. Inside opposites, 1, 2, 3, 4 to the left. So I'm going to write right and left, just so that we're all familiar with what's going on. My original looks something like this. Now I got my new one, looks something like that. Cool. So I just wanted to use different shapes and pictures and stuff. Let's do some more examples. Let's say that I got x minus 2 cubed plus 5. And so I'm starting to get a little bit more complicated. The cube is going to have its own shape, so it has a different shape. The 2 on the inside opposites, this is actually going to go to the right, and then that 5 on the outside is going to go up. And so my original cubic looks something kind of like this. I'm going to go 1, 2 to the right, and 1, 2, 3, 4, 5 up, and then I just redraw that same shape that I had original. Okay, let's do one more like this. So I've got, let's do a square root again. So square root of x plus 4 and then minus 7. Something like that is good. So again, where's this 4 going to go? It's actually going to go to the left, inside opposites, and the minus on the outside is going to go down. And so my original is the square root, something like that. I'm going to go 1, 2, 3, 4 to the left, and 1, 2, 3, 4, 5, 6, 7 down, and then I'm just going to draw the same picture. It's always the same picture. We haven't ever manipulated the picture itself, just where it's located. All right, now let's do some more examples. I'm going to do some reflection stuff. And I'm going to start with, let's do a negative x squared, something like that. It's pretty basic. So my original looks something like that. And notice that there's a minus on the outside. That's a x-axis reflection. And we've already seen this, but basically it should look like that. I'm going to also do a square root of negative x. Notice that the negative's on the inside, which means it's going to be a y-axis reflection. My original square root looks something like that. Y-axis, now it looks like this guy. And again, I'm just trying to make it look good, but this is really hard for me to draw on this side. So, you might be asking, how can you have a square root with a negative on the inside? That doesn't make any sense. Well, what's going on is that you have negative x values here, and the two negatives will cancel and make a positive. There's nothing on this side over here because of what you're saying. There is a negative, and we don't want a negative on the inside of a square root. It would be undefined. So that's why the left half is still around, because two negatives would make a positive. That's a really complicated way of saying just do it this way. All right, so let's do some more, and I'm going to try to show different versions here. Let's do negative x minus 4 squared plus 3. There's a lot going on, but let's try to see if we can graph it. Notice that we have a negative on the outside, and the front is going to be that x-axis reflection. We have a minus 4 on the inside is going to go to the right, and then we have a plus 3 on the outside, which is going to go up. And so my original is a parabola. You can see the 2 there makes it a parabola. So that's my original graph, something kind of like that. I'm going to go to the right. 1, 2, 3, 4. No, hold on. I'm going to go up 3. 1, 2, 3. Cool. So that's my new spot. But then it's this x-axis reflection thing means it's like upside down, basically. And so instead of going up, we're going to go down, and there's your answer. So this here, I kind of cheated a tiny bit. With this x-axis reflection, the way, the order in which you're going to be getting these answers, you should start from the inside and work outward. So move to the right, flip it, and then move up. And that's why we ultimately did move up in the end. But if you're kind of seeing how this flow goes, most of these are not hard. And this is a pretty hard problem in comparison to a lot of the homework questions you'll have on that program. So let me just I want to move on, but let me just real quick look ahead at what we're going to see on the homework. And that's pretty much going to be the hardest problem. I would like to do more technically, but you won't see it, so there we go. Let's do the scaling right quick, and then we'll talk more about homework problems more specifically. So for scaling, that's stretching or shrinking. I'm just going to remind you of some of the stuff, but no, let's just go and do it. So we got a y is equal to, I'm going to make something up here. Let's do a 2x cubed. Let's do squared. Okay, you can handle 2 2's, right? So the 2 in the front here is going to double the height. Double the height, and you can see it's x squared, so it's a parabola. So my original parabola looks something kind of like this. And now I'm going to double its height, which means I'm going to stretch it out vertically. And I guess in a way you can think of it kind of like I'm stretching it top and bottom. I wish I could show you my hands, but basically I'm taking my hand here on the top and the bottom and stretching it out like a rubber band. Like a rubber band. And so it's getting stretched out. Opposed to that, say you got, let's do a 3, a 1/3 there. So then this 1/3 is going to make it a third as high. A third as high. Just high, I guess. So my original now looks like this, but then I want it to be only a third as tall. And so it's actually going to be kind of flat looking. You could have shrunk it or compressed it, if you can say. I splat it so that it kind of goes on the side there. A lot of different ways to kind of see this problem, but the number in the front is either going to make it bigger or smaller, depending if it's a bigger number or a smaller number. Okay. To be able to express how to use the inside, like say that I had, again, I'm just making something up. What if I had a 2x and then say cube? We got a 2 on the inside. If you're going to simplify this, you would distribute, and you would actually end up with an 8x cubed, which now it's on the outside. So this was horizontal for a little bit, but then I simplified it, and all of a sudden it turned into a vertical, and that's confusing. And honestly, it's not on your homework this way. The homework is designed in a way where you can't just do this here, because if you go back through all of these questions that I've done here, even this crazy hard one here, isn't there a way to always get the answer for every single one of these? Desmos. Desmos Graphing Calculator will do all of the ones I've already done for you. Therefore, the homework is a little different. I'm going to show you some examples of what your homework looks like. And it's not hard if you use the same concepts. So I'm just going to, I guess, pick number 1, and I'll start going through that now. They say that I have f of x minus 3. And the original f of x on the side here, it looks like a zigzag. It looks like a zigzag. So that's my f of x. And then they say minus 3. What's the new graph going to look like? Well, I go down 3, and then I draw a zigzag. So there's your zigzag. As long as it's centered in the exact same spot. That was it. Done. So you can see that this is not hard. Let's do a number 2. Let's say that I have f of x plus 4. And they still have the good old zigzag. And so there's my zigzag for my f of x. And they're saying, now what's the new one? Well, notice that this is now going to travel to the left inside opposites. And so I'm going to go to the left, 1, 2, 3, 4, and then I'm going to draw a zigzag. Wow, look at that. So there's your answer, and you're done. Not hard, you're just matching it up. Okay, let's look at another problem here on the homework. So let's do number 3. I've got f of x plus 1 minus 1. And guess what? They've got a zigzag again. Wow, really? So this plus 1 here is going to the left, and this one on the outside is going down. And so what's my new graph going to look like? I go to the left 1, I go down 1. There's the new center for my zigzag. And so my zigzag will look something like this. And there you go. That's it. Not hard at all. As long as you know the concepts, we're good to go. So, and I don't want to do every single one of these homework problems with you, but I think that it's good to kind of see what's going on. Here's a more difficult one. Here we go. So number 4, I've got negative f of x minus 4 minus 1, and my original f of x is actually something that I call hilltop. Looks something like that. I call it hilltop. And so we got hilltop, and that's my original, and they say, now what are we going to have? Well, notice that we have here an x-axis reflection, and so it's going to be flipped upside down, and this is going to move it to the right, and this is going to move it down. And so my ultimate answer in the end here is going to be 1, 2, 3, 4, 1. This is the new center right there, but again, that's basically that point. And it's got to be flipped upside down. And so my hilltop is now like a bowl, I guess you can say. And so it's going to end up looking a lot more like this here in the end. There you go. So it's now like a bowl, or like a dipper, the Little Dipper. A, B, C, or D, a lot of these are pretty easy to match up when it comes to multiple choice. And that's what the homework looks like. It's multiple choice. You click the right one, and you move on. So although it's different, it's not hard. But here's the reason, again, why they're using these is because you cannot type this into Desmos. Desmos graphing will not help you here at all because how can you draw hilltop into Desmos? What's that function supposed to be? You can't. So I guess that's kind of like a cheat preventative, I guess. I don't know if it's actually effective, but we try. So the last one here, and then I think I got one more I want to talk about. This says I got 2f of x minus 3 and then plus 2. And let's do hilltop again, because we've done too many ziggy-zags. So another hilltop is fine. There's another shape that they often use as antenna. So there's like two little antennas. But let's talk about it. So we got double the height. Okay, double the height. I have moving to the left. No. Sorry. Inside opposites, going to the right. Whew. I didn't mess up on the last one, did I? Yeah, see, right. Okay. And then going up. It happens. I mean, it's weird sometimes, but, solve for x, you get a positive 3. Okay, so my hilltop, I'm going to go to the right. 1, 2, 3, going up 2. So this is my new center, but again, that's that point right there. And then I'm going to double its height. So the hilltop's actually going to be really tall, and then it's going to come down a lot as well. It should still end up being at 0 in the end. So there you go. I'm stretching it out vertically like that, okay? Not perfect, but hopefully you're getting the idea. A, B, C, or D, you definitely should be able to get it. And looking through the homework, looking for one in particular that was kind of different. Don't really see it. And that's, oh, there it is. Number 6. You can see that this is just a little different than the normal lectures we have. So they have a 2f of 1/2 x. This is a good classic problem here. And again, their f here is going to be hilltop again. So we're talking hilltop. Okay, so we got hilltop and we're supposed to do stuff. Well, this 2 on the outside is supposed to double the height. And that 1/2 on the inside is horizontal, okay? It's not going to be half as wide. That's actually incorrect because inside what? Inside opposites. So it's not half as wide. It's double the width. It's twice as wide. So it's twice as high, twice as wide. What's the new graph look like? Well, it's actually just zoomed in. So here, I wonder if I could just zoom in here. There's your answer. There it is. I know, that was kind of dorky. Well, so I'm going to try to emulate the twice as big. There you go. There. I don't know. I'm just trying to make it twice as wide, twice as tall. Cool. And now for the last question that is just strange. And I'm going to do only part of it with you because I want you to do the last part on your own. However terrible that sounds. So I have f of x is equal to 3.5 square root of x and then plus 24.3. And they start off by saying, well, what's going on? In part A, you're going to be stretching this vertically by the 3.5, and then you're going to shift it up by the 24.3. Click that answer. That's multiple choice stuff. You click that. All right, not too hard. Part B is kind of weird. They start with saying, well, x is in months, and it's months from birth. They're talking about like weights or something, I think, or heights. Heights of babies. Okay, so heights of baby after birth. And so part B says then we got 48 months. And so you guessed it, x is equal to 48. Awesome. And so I'm just going to plug that in. And most certainly, you should be using a calculator for this one. So here we go. 3.5 times the square root of 48, and then plus the 24.3. And the answer is 48.548. They want it rounded to 1/10 to the nearest tenth of an inch. So it would be just the 48.5 inches, I guess is what the answer is. Cool. That's not too bad. Part C, it says, how well is this something described? And blah, blah, blah. Click very well. It describes it very well. The other option is poorly, but this is, you just click very well. All right. Part D, and then there's actually a part E also, but I'm not going to do that one for you because I want to show you the part D and leave you to do the last one here, okay? So part D now says, what's the average rate of change from birth to 10 months? Okay. Birth in months is what? 0 months old. So 0 to 10. And those are both going to be x values. Average rate of change is the same as saying slope. And so we need to go back to our slope formula, y2 minus y1 over x2 minus x1, just like that. I don't know what my y values are, but I do know my x values are going to be the 10 and the 0. In order to find out what those y values are going to be, you've got to plug them in. And so I'm now going to work on this individually. I got the 3.5 square root of 10 plus the 24.3, and I need to find out what that is. Calculator time. And sorry for that 5 looking so terribly. I'm just not good at drawing 5s. Plus 24.3, and I've got 35.3679. I think they still want only one decimal place, but and so I need to plug in the 0, and you can see what happens there. I get 24.3 here. That's easy enough. So those are my two y values. This is y2, this is y1, and so now I'm going to just basically copy those in there. So 35.3679, I'm going to verify that I'm going to get the right answer by just leaving all the decimals on there. I have always been taught that we should not round until the end, and so I'm not going to round until the end. Just like I was taught back in the day, because that's proper. You're not going to actually supposed to round as you go. That's not right at all. And so let me verify that I'm going to get the right answer. I got 1.10679, and their answer was one decimal place, 1.1. So check mark. That was awesome. We did it right. So the next part basically just gives you two different x values, and then they say repeat. So you can do the exact same procedure and find out what that rate of change is as well. Okay, so it's the same procedure, not hard. It's long, it's kind of weird, but that's what they're wanting, and that's what we got to do. And now we're done. So thank you very much, and have a great day.